Question 7b, we're to determine the percentage by mass of chromium in the ore. So let's go back to look at what the question says. So we've got this chromite ore, which is this stuff here. Percentage of chromium can be determined. So we've got 5.25 gram sample. So that's going to be the total mass of the ore. And we really want to find out what mass have we got of this stuff here, this chromite. So we're heating it, and then it looks as if what's coming out is this stuff here, which we're then dissolving in water to produce these chromate ions. The mixture is filtered, so we're getting rid of all these horrible brown precipitates. We're just leaving these chromate ions. And the alkaline solution is made up to 1 dm cubed. That's 25 centimetre cubed sample is taken out, so we're going to have to take account of some of the change in the number of moles between the 25 centimetres cubed and the 1 decimetre cubed. And then an excess of aqueous potassium iodide is added, so we get a redox reaction between the I- ions, the chromate ions, and the water, and 1 mole of chromate forms 1.5 moles of iodine. Surely that's going to be useful to us. Then it's a standard titration now between iodine and sodium thiosulfate, and the average titer of thiosulfate is given. So in these questions it's always a good idea to work backwards. So we're going to first start off by working out the amount of thiosulfate that we've got, and we're going to use concentration times volume there. So our typical formula, remembering to turn everything into decimeters cubed for volumes, so concentration 0.1 times the volume of 25.5 times 10 to the minus 3 to convert us into decimeters cubed. So 25.5 times 10 to the minus 3, and I can do that in my head, 2.55 times 10 to the minus 3, and let's put the units on, moles. Okay, now we've got to start using our ratios. So the iodine is linked to the chromate. Iodine linked to chromate, so we've got to make sure that we find out what the number of moles of iodine is. So Ni2 equals, well, if we look at the equation, that's going to be half the number of moles of thiosulfate, because when there's 2 of thiosulfate, there's only 1 of iodine. So that is going to be half the number of moles of S2O3 2 minus, which in this case 2.55 times 10 to the minus 3 times a half is 1.275 times 10 to the minus 3 moles. Now we're not quite there yet, we need to do a few more steps. We've got the iodine, now we need to work out the chromate. So 1.5 moles of iodine gives us 1 mole of chromate, so 1 mole of iodine is going to give us 1 over 1.5, 2/3 of a mole of chromate. So we need to essentially divide by 1.5 to get our number of moles of chromate. So NCrO4 2 minus, N for number of moles, is going to be 2/3 of the amount of iodine, or it's the same as dividing by 3/2. Divide by 1.5, and we get this number here, 8.5 times 10 to the minus 4 moles. Now, where did that chromate come from? Well, we've got the number of moles of chromate, so 4 moles of chromate ions. So now, at this point, it's time to start thinking about the number of moles. And this is, remember, in 25 centimeters cubed. And so now we need to think about how many moles there are in 1 decimeter cubed, or 1,000 centimeters cubed. So the number of moles of chromate ions is going to be equal to 1,000 divided by 25 multiplied by 8.5 times 10 to the minus 4, which is times by 1,000 divided by 25, 0.034 moles in 1 dm cubed. Now we just need to do a little bit of more reacting ratio stuff, so we're up to here. We've got the number of moles of chromate ions that came from here, but remember that 4 moles of chromate ions came from 2 moles of chromite. So the number of moles of FeCrO2 is going to be a half of the number of moles of chromate, which is 0.034 divided by 2, which is 0.017 moles. Okay, we've done a lot of work with the reacting ratios. Let's see, so now we've got to find the percentage by mass, so we need to turn that into a mass. Mass of FeCrO2 twice is going to be its molar mass, so we get our periodic table out. Let's work it out here, so molar mass, FeCrO2 twice, always worth having this on the script. So molar mass of that, well, chromium is 52, and there's going to be 2 chromiums. There's going to be 4 oxygens, oxygen 16, 4 times 16, and there's going to be 1 iron, iron 55.8. So total of that, 223.8 grams per mole. So now we need to do 223.8 times 0.017, which is 3.8046 grams. We'll keep it at that in the unrounded form for now. We're going to do some rounding at the end, I'm sure, as we work out, it says 1 decimal place. Now, is that reasonable? 5.25 grams we started with, 3.8 grams. Seems reasonable. This is probably a decent commercial ore if that's the type of percentage we're talking about. We finally work it out. Percentage, percentage of chromium in a sample of chromite ore. So now we actually have to do a little bit more work here. So we're not just working out the percentage that is this, but we need to work out the mass of actual chromium that's involved. So now we need to do a little bit more work, and perhaps it would be better off if we hadn't done this mass conversion immediately, because remember that the number of moles of chromium is just twice, because we've got 2 chromiums, the number of moles of the chromite. So actually, if I'd read the question carefully, I would have actually missed out those last steps. So it doesn't really matter, we can always go back. 2 times the number of moles of that, which is actually just the number of moles of chromate, so 0.034. Mass of chromium, easier calculation, we just need to work out that chromium we found from the periodic table is 52, so 52 times 0.034, 1.768 grams, and percentage by mass of chromium, yes, should have read that more carefully. So percentage of chromium is going to be 1.768 divided by 5.25 times 100 33.7% to 1D.